In this video for section 3.3, we're going to talk about how to compute z-scores, or standardized data values. And we do this if we want to compare values that come from two data sets with different means and standard deviations. So an example of this is if we want to compare a man and a woman and see who is relatively taller compared to other people of their gender. A z-score represents how many standard deviations a data value is above or below the mean. For example, a z-score of positive 2 would represent a data value that is 2 standard deviations above the mean. Now, the formula for calculating z-scores is the same. It's just the symbols depend on whether we're looking at a population or a sample. But what we do is we take our original data value, x, we subtract the mean, whether it's population mean or sample mean, and we divide by the standard deviation, whether it's population or sample standard deviation. That gives us the z-score. So we're going to look at this business application problem. The Ames hiring test has an average score of 2,000 and a standard deviation of 200. The BHS screen test has an average score of 80 with a standard deviation of 12. John took the Ames hiring test and scored 2,344, whereas Mary took the BHS screen test and scored 95. Who had the better score? So we know that they both scored above average on the test, but since the tests have different means and standard deviations, we can't compare them directly, but we can calculate the z-scores. So I'm going to start by calculating a z-score for John. I take his score, 2,344, and I subtract the mean, which was 2,000. Then divide by the standard deviation, which was 200. That gives us 344 divided by 200, and if I do that on a calculator, I get 1.72. So John's score was 1.72 standard deviations above the mean. Negative z-scores would be below the mean, positive z-scores would be above the mean. Mary's score was 95, and the mean on her test was 80, and the standard deviation was 12. So 95 minus 80 divided by 12. That's 15 divided by 12, which is 1.25. So her score was 1.25 standard deviations above the mean. So John had the better score because his score was more above the mean than Mary's.